In this lesson, I'm going to be showing you how to factor advanced polynomials completely. And we're looking at instances where you have to factor a few more times than we did in the video where we're just looking at factoring polynomials completely. And we're going to introduce a few new things here. So what are we going to do? We're going to spend some time reviewing simple factoring. We're going to also take a look at difference of two squares. Then we're going to look at the sum and difference of cubes, of two cubes. Then we're going to look at the steps. The steps are very similar with just the other topic on just factoring polynomials completely. The only difference here is we're going to introduce a few more times that we're going to be repeating the steps of factoring. And then we're going to look at some examples together. So basic factoring it involves expressing a trinomial or a polynomial as a product of its factors. So simply put, x squared plus 5x minus 14 is the same as multiplying x minus 2 by x plus 7. The difference of two squares, if I have x squared minus y squared, so always remember that these are going to be perfect squares, it's the same as x plus y multiplied by x minus y. Now let's look at the sum and difference of two cubes. If I have two cubes, x cubed minus y cubed, this is the difference here, is going to be the same as x minus y multiplied by x squared plus xy plus y squared. Now for the sum of two cubes, pay attention here to the fact that these are always alternating signs. And the sign here on the x minus y represents whether you have a sum or difference. Now the sum of two cubes is represented as x plus y multiplied by x squared minus xy plus y squared. Also note the change in signs, the alternating signs. Now how do you go about this? It's simply we're just going to keep factoring until we get to the point where we can factor no more. So we're going to factor the original polynomial and then look for the factors of that polynomial and make sure that that polynomial cannot be factored any further. You keep doing that until you get to a point where you have the polynomial at its lowest form, at its simplest form. Now let's look at some examples together. Here I'm going to bring in a lot of different ideas. One idea also is grouping. We're going to factor by grouping. So I'm going to group these polynomials together. Let's do this right here so we can get a greatest common factor. So we have a greatest common factor here of x to the power of 4. And then the other factor, when we divide each of these terms by x to the power of 4, we are left with x squared minus 1. And then here we have negative x squared minus 1. So we're going to end up with, actually there was going to be a plus here, that's it as an error. So that's going to be minus 1, and then we have x squared minus 1. Okay. So now what we're going to do here is we've discovered our greatest common factor here is x squared minus 1, x squared minus 1, and then the other factors are x to the power of 4 minus 1. Okay, now we're going to remember our difference of two squares. So let's go ahead and write the formula here. A squared minus b squared is a plus b multiplied by a minus b. So x squared minus 1, x squared minus 1 is the same as x squared minus 1 squared. So this is going to give us x plus 1, x minus 1. All right, let's go to x to the power of 4 minus 1. This is going to be the same as x squared minus 1 squared. So this is going to give us x squared minus 1 multiplied by x squared plus 1. So now we're going to replace each of these terms with their factored forms. So we have x plus 1 x minus 1. Then we have, by the way, we're not done. Okay, let me show you why we're not done. We have x squared minus 1 multiplied by x squared plus 1. So here, x squared minus 1, again, is a difference of two squares. And like we did up here, it's going to be x plus 1 multiplied by x minus 1. So let's go ahead and put that here. X plus 1, x minus 1, x squared minus 1 is going to be, also we have x plus 1 there. So we have x plus 1, and then we have x minus 1, and then we have x squared plus 1. So here you can actually, this is okay, but because you're a more advanced math student, it doesn't help to leave it this way. It can show your knowledge of math by saying this is the same as x plus 1 squared, x minus 1 squared, and then x squared plus 1. So that is the final result that makes a lot of sense for you. But if you leave it in this form, it's also fine. This form I like more because it just shows that you understand, you have a better understanding of working with expressions and exponents. All right, let's look at this next one. X to the third power minus 3x squared minus x minus 3. This is an error here. Okay, so it should be a plus 3. So let's go ahead and group. Let's group right here. So this is going to be x squared multiplied by x minus 3 minus 1 multiplied by x minus 3. So we have a common factor, greatest common factor of x minus 3, and then we multiply that by x squared minus 1. Okay, so now we're going to focus on our difference of two squares, which is a squared minus b squared, which is a plus b multiplied by a minus b. So x squared minus 1 is going to be x plus 1. We did that in the previous question, x minus 1. So this is going to end up being x minus 3, and then we replace x squared minus 1 with its factors. This is going to be x plus 1, and then x minus 1. That is final answer. So now we have x to the power of 8 minus 81. So x to the power of 8 minus 81. Let's remember our a squared minus b squared equal to a plus b multiplied by a minus b. So one of the things you will notice with the way I do math is that I believe in repetition. So no matter how many times I see a problem like this, I will keep repeating the formula just so it becomes second nature. You don't always have to memorize or cram, or, it just becomes second nature. And so this now becomes x to the fourth power minus, this is squared, minus 9 squared. So 9 to the second power. So this is going to give me x to the fourth power plus 9, and then x to the fourth power minus 9. So now we have x to the fourth power minus 9. This is also a difference of two squares. This is going to be x squared squared minus 3 squared. Now this is going to be x squared plus 3, and then you have x squared minus 3. Now it depends on what level of math you're doing. We can still go further with x squared minus 3. So let's see, x squared minus 3. This is going to be x squared minus the square root of 3 squared. So this is going to give you x minus root 3 multiplied by x plus root 3. So this most likely you will see for students who are in this type of question, you will see mostly for students probably in Algebra 2 and maybe some early part of pre-calculus. That's where you'll see a lot of this. So now let's go ahead and try to bring all of this together. So we have x to the power of 4 plus 9, okay? Now we have x to the power of 4 minus 9 gives us x to the power of 2 plus 3. And now we're left with x minus root 3 and then x plus root 3. So this is really all you need to do for this type of questions. Now let's try a final example together. Let's group our common terms together. So we have x to the power of 6 as a common factor. So we have x to the power of 6. And then that's our greatest common factor. And we're left with x squared minus 4. And then minus 1. And then we have x squared minus 4. Okay. What we're now going to do is we're going to find our greatest common factor, which is going to be x squared minus 4. And then our other factors are x to the power of 6 minus 1. So now let's go ahead and write our difference of two squares. A squared minus b squared is equal to a plus b multiplied by a minus b. So let's do that for each of these. X squared minus 4. X squared minus 4 is the same as x squared minus 2 squared. So this is going to give us x plus 2 multiplied by x minus 2. Then we'll do the same for x to the power of 6 minus 1. This is going to give us x to the power of 3 squared minus 1 squared. So this is going to give us x to the power of 3 minus 1 multiplied by x to the power of 3 plus 1. So now let's look at our sum and difference of cubes, because that's what we have here. So I'm going to write one formula and show you how to apply it to both. So you now have x cubed minus y cubed is going to be equal to, I'm going to put a plus above, so it's going to be x plus minus y, and I'll show you how to apply this. X squared minus plus xy plus y squared. So all I'm saying here is that you're going to, if it's x cubed plus y cubed, your x is going to have the plus y, and then in your quadratic term, in the parentheses, you'll use the opposite sign for the middle term. So let's go ahead and look at x cubed minus 1, which is going to give us x minus 1 multiplied by x squared plus x plus 1. And then x cubed plus 1 is going to give us x plus 1 multiplied by x squared minus x plus 1. So now we're going to replace all of this. This is going to be a really long expression. So we're going to have x squared minus 4 is going to give us x plus 2 multiplied by x minus 2. X to the power of 6 minus 1, let's focus on x to the power of 3 minus 1 first. So this is going to give us x minus 1 multiplied by x squared plus x plus 1. And then we have x plus 1 multiplied by x squared minus x plus 1. So let's go ahead and write the whole expression. Let's write all our factors out. So we have x plus 2, x minus 2, x minus 1, x plus 1, x squared plus x plus 1, x squared minus x plus 1. So these are the factors of that expression.